So, good afternoon, everyone. Myself, Roshan, and I'm from Lovely Professional University. So, in this video, we are going to discuss what is binary tree and what is complete binary tree and what is full binary tree and what is almost complete binary tree. So, if you are new to this video, so please like and share with your friends. So, I'm going to explain all of these topics. Basically, what is a binary tree? So, binary tree is the tree or the fundamental data structure in computer science which deals with various type of algorithms and data storage. So tree consists of nodes and branches. So each node contains two child nodes. You can see that there is one node. Each node consists of two child nodes. So coming to the full binary tree. So a full binary tree is a binary tree where each node has either zero or two children. So each node, we can see that each node should have either zero or either two children. So what is the properties of full binary tree? So in the full binary tree, we can see that it is properties to efficient storage and data transfer. So again, what are the applications used for the full binary tree? So we are going to discuss the applications also in the full binary tree. So there should be a root element and there should be a interval nodes. There should be as leaf node. So this is the leaf node and it has interval. This is the interval nodes and there should be a root node. A can be considered as a root node. So, the main important thing is it should not contain no loops. It should not contain loops. So this is the main property in that binary in the full binary tree. So every tree is considered as a binary tree, but there are specific conditions that either it should have zero or two children. So uh, coming to the almost complete binary tree. So almost complete binary tree means, so the first node should we have to complete the first node, then we have to go to the right node. Without completing the left node, if we go to the right node means the complete binary tree should not satisfy the condition. So you can see that almost complete binary tree is a binary tree where all levels are completely filled except the last level. So I already explained the topic. So you can see the last level characteristics are like the last level can have nodes on the left side but no empty spots in the middle. What are the use cases for the almost complete binary tree is to you can see that efficient memory allocations and implementations of priority and queues. So and coming to the complete binary tree. So complete binary tree is a binary tree where all levels are complete filled except the expect filled and except possibility the last level, except the last level, it is called a complete binary tree. So what are the properties like predictable storage and allocation memory and fast transfer traversal? So I will explain you what is traversal and in detail. So first we are going to discuss the types of binary trees and the last comparing full versus almost complete binary tree. So full binary tree is more rigid and almost complete binary trees are more flexible. So complete binary tree, almost complete binary tree is more flexible than full binary tree, and complete versus others, they're easily transversal compared to other trees. Traversal is easy, so that's why we use complete binary tree in implementing the data structure and algorithm. We can use any other trees like full binary tree and almost complete and complete binary tree. We can use any of the types. There are no difference between that the specific thing like we have to use this thing only, not another tree. We can use the trees, but but comparing to the functionalities, there are different conditions on using these binary trees. So you can see that the algorithms applications, based on the application, we can use any of the binary tree. So I'm going to explain traversal also in this video. So one second. So you can got the difference between the binary tree and full binary tree and almost complete binary tree and perfect binary tree. So I explained you all of the topics. So the main difference is like I'm going to tell you that in almost complete binary tree, so the left element should be filled and the left node should be filled, and after that, then on right child should be filled. So full binary tree should consider at least a full binary tree can also consider as a street binary tree. So we can also call this as street binary tree. So traversal can easily possible in this. So I'm going to explain you the topics. One second. So I'm going to explain you the traversal, what is tree traversal, and what is pre-order, in order, and post order. I will explain you. One second. Mm, okay. So coming to the tree traversal, what is tree traversal? So in the tree traversal, so this is called the traversal. So if you see this means you will get blur. Actually, I created the video, but my video the screen is not recorded. That's why I'm giving you. That's why doing another video. So sorry for the inconvenience. I just forgot to add my screen. So that's the reason my video got wasted. So I'm creating another video about this. Binary trees. So I'm just explaining you the topics, like not I'm not going to do from the scratch onwards. So I will just you explain the topics. It will be like very easy. What is tree traversal? First I am considering one tree, like x, y, and z. What is pre-order? Pre-order means it should first element should be like a root element. So in pre-order, the traversal starts from here. So we are going to consider the traversal. So x, y, and z. So in pre-order, the first element should be the root element, and the second element should be the left node, and third element should be the right node. So what is in order? So in order, there should be left node, and there should be root element, and there should be right node. What is post order? So pre-order, in order, and post order. Post order should be like left node and right node and root node. So this is called pre-order, in order, and traversal. So how can we write this? So pre-order means first thing we have to consider root element, that is x, and then we have to consider the right element y, and then we have to consider the right element z. So x, y, z is a pre-order, and in order is left element y, and root element is x, and the right element is z. This is called in order. And what is post order? We can see that the first element should be the y, left, and the second element should be the right z, and third element should be the root element. So this is the tree traversal of a, this is the example of tree traversal. You can see that this is the example of a tree traversal. This is the example of tree traversal. We are going to consider the one hard tree traversal. So I'm going to discuss the hard tree traversal. So I'm taking this f, b, z, and a, d, c, e, and V, and H. So I'm taking this as a tree traversal. So first thing, what is pre-order? The traversal starts from F. So I'm going to consider as F as my pre-order, and later on it travels from B to F to B. So consider as the pre-order as B, and later on it travels from A. So I'm considered as first time it was traveling. So that's why we take as pre-order. If it travels first time, we will take as pre-order. Two times traveling means in order, and three times traveling is post order. So this is the difference between pre-order, in order, and post order. So first my f was traveling to b, so I'm considering f, and I'm root element as f, so it is pre-order. So b, it is pre-order, and it is traveling to a, so it is pre-order. And a2, we are considering two child nodes, so there is no node in it, that's why we are considering for a we are two child nodes. So a2 again a, so it travels to a to another a, so we consider as in order. And a2 again it was went here to here, so post node. So again it went to b. So what is b? Two times it went, that's why in order. So from b to again it went to d. So d is first time it was going, that's why we are considering as in pre-order. So and D2 again it went for C. You can see from D2 it went to C. So first time pre-order we are going to consider. You can see pre-order as here. So again it's C2. Again it went to child nodes. It passes to a child node and it went to C again. So in order we are considering for again it went to C. So post order. So in C it went to D. Again it went to D. From here it went also, and again it went. So we are considering as in order. Two times it went. So from D2 it went to E. First time it went. So we are going to consider as E as pre-order. Again it went to itself as in order, and again it went to itself as post order. From the post order it again went to D. So we are considered two times D. So we are going to consider two times as in order, and again it went to B. Again it went to F. So we are going to consider as B and B to F, and we are going to consider as uh, in order. In order. So from the F it went to G. So from G we are going to consider as in order, pre-order, and again G2 itself as in order, and it went to V, and we are going to consider as V first time as pre-order, and V to H, and H2 itself in order, and post order again it went to V, and again it went to G. So this is called the traversal. I hope you got idea about what is traversal and what are the types of traversals. So in order, pre-order, and post order. So I'm going to explain you the insertion and deletion also. So first of all, I am going to explain you in what is insertion. So I'm taking here 4, 2, 3, 6, 5, and 7 and 1 as an example for insertion. One second. So I'm explaining the insertion topic, right? So I'm taking here as what is insertion and what are the types of insertion and what is binary search tree. So what is binary search tree? So I'm writing here binary binary search tree. I'm writing what is binary search tree. What is search? We already discussed what are the trees, what are the types of trees. Actually, I made the video, but the thing is, the video I made is screen is not recorded, so I'm making it again. So there's a lot of effort in making another video. So that's why I am not drawing the diagrams again. So I'm just going to explain what is binary. So I'm just explaining the topics. What is binary search tree? What is search mean? So the search meaning is like the left node should always less than the root element. Okay, so the left node should like 2 should less than 4. That's why we are considering 2 here. So again I'm going to consider as I'm going to take in an example. I will draw one example. So a 10, 9, and 8. So I'm going to take here 10. I'm going to take here 9, and I'm going to take here 8. Sorry, mistakes are happening. It's okay. 8. Okay. So I'm drawing the lines here to here. So the left element should always less than the right node. So it should always have to be less than the right node. So 9 is less than 10. So we consider as it is as binary search tree. But the right element should always greater, so it should be less, left element should be less than the root element, but the right element should always greater than the root element, so we will consider 8. So that's the difference between, but it is 8 is less than, so we are not going to consider 8, so we are going to write what we have to write, 11. Instead of 8 we are going to write 11. So that's the difference between binary search tree and the binary tree and the binary search tree. So we are going to insert these values we are going to insert these values in binary search tree. So I will insert, first we are considering 4 as root element. So the second element is 2. So 2 where we have to consider the left element, because the left element should always less than, so we are consider 2 element, and the next element is 3. So 3 where we have to consider at right. 2, we can see that 3 is considered as right. So again 6 element, so 6 should be considered as right to this root element, because the root should be less than the right node, means the element should be always greater than the root element. So 6 is we have taken 6, and the next thing is 5. So it should be less, so we consider 5 here, and 7 we consider right, because it is greater than the from 6, and 4 it is greater element, so that's why we are considering here right. For 1 we are considering the left node as 1, so because it is less, that's the reason I mentioned, already mentioned, the root element should always less than the root elements, and it should be greater than the right nodes are always greater than the uh, root element. So I hope you got the idea about the binary search tree and insertion. So deletion is also the similar topic. So I don't want to explain. I want to explain, but the time deadline is approaching. So the thing is, we performed we performed what is binary tree, what are the types of binary tree, and what is binary search, and in that what is insertion, and how can we insert the elements, what are the conditions for inserting, we all discussed here. So I'm going to write the code for the binary search for insertion, deletion, and transversal, pre-order, in order, post order. I'm going to explain all the details in that code. So I will explain you the code, how to write the code. So guys, I'm sure I'm going to write the code for this. 1 second. Yes. So I already created. Now I can't able to write all the code again. So I already did it, but I'm going to explain you. So I taken here class as tree node, and I'm going to defining initializing the self keys like self dot left equals to none, and I'm going to initializing the self dot right equals to none, and the values are as key values. I'm defining the another function insert and the deletion, and a minimum value in order transversal, pre-order transversal, post-order transversal. So I'm going to insert the values 30, 20, 40, 60, 70, 60, and 80. So I'm going to print in order transversal, and pre-order transversal, and post-order transversal. If I run the code, I can get the values like 20, 30, 40, 50, 60, 70, and 80. What is in order transversal? We already discussed. So what is in order, what is pre-order, and post-order? Three times it was, first time it was passing means in order, two times it was passing means pre-order, and three times it was passing means post-order transversal. So you got the idea about in order, pre-order, and post-order. I will explain you the code and how we write the code. So first of all, I'm inserting the root values here, and if the key value is less than the root value, so I'm inserting the left key, or else inserting the right key. So I'm defining the delete also, insertion and deletion both are performing here. So if root is none, return root. So in that root, if the key value is less than the root, I'm again deleting the root value, and if the key value is greater than the root value, I'm deleting the right root. So else I'm considering one temperature as a root dot right, and the root is nothing but none. Why we are taking none? Or else we can't able to perform the code. That's the reason I took the temperature as constant. So if root dot right is none and the temperature is root dot left, and for that I'm going to returning the temperature. So you can see, so temperature, what is temperature? The constant value, the minimum value of the node is root dot right. So the root dot value is the temperature value, and the root dot right is the delete root dot right from the temperature value. So you can see the what is minimum value node. We are taking the minimum value node. I'm defining the function for this node. It is a current node, and the while loop I'm using, and the return statement I'm using, and again I'm taking like defining in order transversal. I explained you the left in order transversal, and I'm taking the pre-order transversal, and again I'm taking the post-order transversal. After that I use some if statements here, root dot left, root dot right. Here also I used root dot left, root dot right, and I consider root as none, and root again I consider as root dot 50, 30, 20, 40, 70, 60, and 80. So I printed the values for in order traversal, and in order traversal I consider root elements. For pre-order traversal I consider root elements. This also consider root elements. So by printing this, we got the outputs like in order, pre-order, and post-order. So this is what about the complete topic about the binary tree. I hope you like the video. If you like the video, share it with your friends, and thank you so much for watching this video. We will post some more videos about the topics in future. So thank you so much guys for watching this video. Please share it with your friends, and I hope you like the video. So thank you so much.